Hey guys, and welcome back to how to make elements from household materials. And today's element is going to be zirconium. Now, zirconium is found in abrasives such as sandpaper, and I picked up these sanding belts here from Canadian Tire. They're about 40 grit, and they say they contain zirconium dioxide. This is key because some other sandpapers contain things such as silica, which is sand, and these will not work for this experiment. So we're going to be removing the zirconium dioxide from these grinding belts here, and then reducing them with the lithium dissolved into some molten lithium chloride to get our zirconium metal. First, we're just going to need to remove it from the sandpaper though, so I started by chopping everything up with scissors into a bunch of little strips. We're then going to go ahead and burn off the adhesives and organic material. So you can see here, I've crammed everything into this steel jar here, and we're just heating it up on a camping stove. I'm also using a blowtorch to heat up the material, and this is just burning off all of the organic material, and this must be done outside because it smells really bad and is releasing things that probably aren't the best to breathe in. After burning everything, you can see that this didn't totally react. There's still lots of carbon and other organics which only partially decomposed, so we're going to be using some potassium nitrate, which we made in a previous video, and you can go check that out, and we're going to be using this potassium nitrate to oxidize those organics directly to carbon dioxide. This will also form things such as potassium carbonate and other soluble products which we will be able to dissolve off in water afterwards, leaving us with our zirconium dioxide. So I weighed out an amount of potassium nitrate. Doesn't really matter exactly how much, but probably around twice as much as the zirconium dioxide that you have. And this was all blended together in a magic bullet. We blended it just to get everything mixed well together, and we really just need an excess of potassium nitrate to oxidize everything properly. It was then set on fire, and you can see that it's burning fairly slowly but steadily as the organics are being burnt away. After the reaction, I took some water and added it to this mixture and broke up the chunks. Then I mixed everything together to get any soluble things dissolved. The zirconium dioxide is quite heavy and easily sinks to the bottom, and any of the other ash or other byproducts which weren't actually oxidized should be suspended in the mixture because they'll just be like dust. So what I did was I washed this several times, as you can see, and we just poured in some water, mixed it around, dumped off anything suspended, and repeated this. We know that it's done as soon as you do a washing and the water above is totally clear and doesn't have any more suspended stuff anymore. Next, it was dried, and I got around 50 grams of zirconium dioxide. So we're going to be using about 10 grams of this to test it first with actually extracting the zirconium, and I'll set aside the other 40 grams. So it does look like there's about 25 grams per belt, so that gives you an idea of how many things of sandpaper you need depending on how much zirconium you want to make. So the lithium is what we're going to be using to reduce some zirconium dioxide to the zirconium, but the zirconium dioxide won't melt until a very high temperature, so we're going to need to employ the solubility of lithium in molten alkali halide salts to reduce the zirconium dioxide. So basically, we're going to take our lithium and dissolve it into some molten lithium chloride, and because the lithium is in a dissolved phase, it will react with the zirconium dioxide more easily, and it should be reduced to the zirconium metal more efficiently at least. So first I took 10 grams of this zirconium dioxide and ground it into a fine powder to increase the surface area. Surface area is key in this reaction because our zirconium dioxide is going to stay as a solid throughout the entire reaction. We also needed to prepare some lithium chloride. So first, 3 grams of lithium metal was added to some water to make some lithium hydroxide. This generates hydrogen, so this must be done outside or in a fume hood, as hydrogen is flammable and explosive. The lithium metal was simply removed from a battery in a previous video, and you can go check out how to do that. After adding all the lithium to the water to form the lithium hydroxide, we're going to need to be adding some hydrochloric acid to neutralize it and make our lithium chloride. Now, I used pH strips to track the pH until it was around 7, but I overshot a little bit. That's not the end of the world because any residual hydrochloric acid can be easily evaporated off when you're boiling down your solution to obtain your lithium chloride. So lithium chloride will absorb water from the air, so after boiling it completely dry, it's important to work fast with it and limit its exposure to air. So I took all of our lithium chloride formed and the 10 grams of zirconium dioxide that we'd previously blended into a fine powder, and I blended these two materials together. It's important to get an intimate mix of these two so that when we do the reaction, there's a higher chance that everything will come together properly, dissolve together, and will actually reduce our zirconium dioxide to zirconium. So while that was all blending, I designed a steel apparatus to do the reaction in, and this is just out of some steel pipe from Home Depot. I basically melted this all together, except for one joint. I melted it all together with an arc furnace, just so that there's less of a chance of having any leaks or anything, because we really don't want any of our lithium chloride to be leaking through some joints. You could also use a welder if you have a welder. I personally don't have a welder, but I built an arc furnace and just melting these chunks together worked totally fine. So I took some lithium metal and I chopped it into some small pieces and mixed it with the zirconium dioxide and lithium chloride mixture. Once again, lithium metal can easily be removed from batteries, and I showed how to do this in a separate video. Everything was then loaded into the apparatus and lowered into a fire brick. I got this fire brick from a pottery supply store, and they're fairly easily to find at a lot of different suppliers which make things such as pottery kilns, and they're pretty good up to very high temperatures, around 2,300 degrees Fahrenheit, and they're very, very good at insulating. As a side note, I also did add a tiny amount of mineral oil into the apparatus to displace any air as the mineral oil vaporized. This will just help to prevent the lithium from reacting with any oxygen initially in the apparatus. The apparatus was then heated up using a blowtorch in the side of the fire brick, and I brought this up to a very high temperature until it was glowing pretty much white hot. Lithium chloride melts around 605 degrees Celsius, and at the point which this happens, then the lithium will be able to dissolve into the lithium chloride. Although lithium melts at much lower than 605 degrees Celsius, it will react with the zirconium dioxide fairly slowly, just because the lithium has a tendency to form oxide layers due to how reactive it is, and I just feel like this reaction wouldn't work too well. Furthermore, the lithium is very, very light, and the zirconium dioxide is very heavy, so if you were to not have the lithium chloride, the lithium would likely float on top of the solid zirconium dioxide, and there'd be very little mixing between the two, and very little dissolution occurring. But by adding the lithium chloride in with this whole mixture here, and having the lithium dissolve into a molten lithium chloride solution, it can surround the zirconium dioxide and better reduce it. So I heated this to red hot for 3 hours, and you can see here that it was really, really glowing, like incandescent, basically white. And then once this was done, I allowed it to cool. You probably don't need to heat for 3 hours, but heating it for longer rather than shorter will just ensure that everything reacts. So you can see here that after being cooled, I took apart the apparatus, and it was placed in water to dissolve any lithium chloride and lithium hydroxide which had been formed in the reaction. I left it in the water overnight, and I didn't note any sort of hydrogen evolution at all, which indicates that all of our lithium metal actually reacted with the water, which is excellent. All the lithium metal reacted in the reaction versus reacting with water, which is great because that means that all of our lithium actually did dissolve and react with the zirconium dioxide. So this likely did succeed. So all the solids were filtered from the solution after removing everything from the apparatus and washed a couple times with water. I then took the solids and stirred them in water overnight once again, just to remove any residual lithium chloride and lithium hydroxide which didn't come out in the first water washing. It was then filtered again and dried over heat. So I was left here with this fine zirconium powder, or at least I thought it was zirconium, but there is one very easy way to test for zirconium, and this is by simply burning it in a flame. Zirconium burns in a flame with a yellowish to white color, and sparks are emitted as it burns. This is very characteristic of zirconium, and it's actually used in some fireworks, interestingly enough, for this effect. So as you can see here, we have a little bit of zirconium, and upon dropping it into the small blowtorch, it's very evidently releasing some nice sparks. So this confirms the presence of zirconium metal here, and from all of that we got around 8 grams of zirconium, which is pretty good. Now, based on 100% yield, we would have expected 7.4 grams from the 10 grams of zirconium dioxide used, which corresponds to a 106% yield. This means that we definitely do have some impurities, and perhaps we have some unreacted zirconium dioxide, but this isn't the end of the world, and we definitely did make some zirconium. An improvement to a future attempt, if I were to do this again, would probably be to use a finer grit sandpaper. So instead of using 40 grit sandpaper, if I were to use something such as a 200 grit sandpaper, then the zirconium would already be very, very fine, and it would be easier for it to all react, because this reaction is very dependent on the surface area of the zirconium. Zirconium dioxide. The higher surface area you can get, then the better the reaction will take place. I didn't put all of it into an ampule, I just put some in the ampule as my element collection, but I also did save some just as a regular powder in case we ever need it for any reaction in the future. And we still do have 40 grams of zirconium dioxide, which could easily be used to make more zirconium metal. And I did recover all of the lithium chloride from this process, because the lithium chloride could of course just be recycled. Anyhow, I hope you guys enjoyed this video. This is essentially how to purify zirconium from zirconium dioxide based sandpaper, and I had a lot of fun. I hope you guys enjoyed, and I'll see you in a future video. Cape, bye.